Alright, welcome. This is going to be a video on valence electrons. Yep, valence electrons. So we've already had a chance to talk about this. Hopefully this is more review. Basic definition of valence electrons, they're the electrons at the highest energy level. Let's make that singular. So it's electrons in the highest energy level. Another way we could think about it also is that they're electrons that are on average farthest from the nucleus. They're the electrons that are going to be around the outside of the atom. They're electrons that are going to be taken when bonding occurs. So, next thing we're going to look at here is I just want to give you a little bit of a sense of how to look at valence electrons by the two sort of different models that we've looked at recently. That's going to be Bohr, and that's going to be quantum theory. In the Bohr model, that's where we have the solar system. So here's our nucleus, and then in the Bohr model we have these orbits, these rings that represent the pathways that electrons are taking as they fly around the atom. So you get a little electron here, and that electron is flying around in this orbit. So the idea of a valence electron is going to be the number of electrons that are in this farthest ring out. You can have many different numbers of rings for different atoms depending upon the number of electrons, but the idea is still valence electrons are the number of electrons that are out here on the edge, on the last shell, as they say in the Bohr model. For quantum theory, we don't really do pictures like in Bohr. We do electron configuration. So for something like carbon with its 6 protons, and we assume that it's electrically neutral, so there's 6 electrons. So electron configuration would look something like this, where all the electrons add up to 6, 2, 2, 2, 6. So if we were looking at the valence electrons here, we would look at the electrons on the highest energy level. Remember, energy level is this big number here. So we could look at the big number, 2. We find that it's in 2 spots, and that in the 2s orbital there are 2 electrons. In the 2p orbital there is also 2 electrons. So we got to add them up. 2 plus 2 gives us 4 valence electrons for carbon. Great. Let's look at a slightly more complicated view. Well, maybe not complicated so much as a bigger electron configuration. Let's do, just for example's sake, arsenic. Atomic number 33. So see if you can beat me. Almost done. And then 4p3. That'll give us 33. Same sort of deal here. We want to find the highest energy level. Again, we look at the big numbers and find that the biggest number is 4. We see it here, but we also see it here. Since there are 2 electrons in this 4s orbital and then 3 in 4p, we got to add them together and we get 5 valence electrons. Cool. So hopefully, to synopsize, you understand that valence electrons are the number of electrons in the highest energy level. We see the energy levels as these big numbers here, as in arsenic 4, and we add up the exponents, which represent the number of electrons, to give us our 5 valence electrons. Great.